This is section 5-6, and we are using the hinge theorem and its converse in this section. So the hinge theorem basically says that if we're comparing two triangles. So if we have two side lengths that are congruent in each triangle, then the one with the larger included angle will have a longer side that's opposite it, and the converse. What does that really mean? So that means if this is a triangle and this is a triangle. So if this side length and this side length are congruent, and this side length and this side length are congruent, if this angle is larger than this angle, then this line will be longer than this angle. And they show you an alligator because we can think of it, the jaw of an alligator getting bigger or smaller. So the wider the jaw gets for the alligator, the larger the span is from the top of the jaw to the bottom of the jaw. And the smaller it gets, the smaller the span. So it's the size of the jaw that will not change, but if the angle gets bigger or smaller, this measurement will get bigger or smaller. Okay, so basically we're talking about inequalities here. So we're comparing these two triangles, and we know that this works for the hinge theorem because this side and this side are congruent, and this side and this side are congruent. So we're talking about the included angle, which is the angle that's made up by those two sides. So we have the measure of ACB. So where is ACB? ACB is here, and GDE is here. So we're going to look directly across from it, and we're going to keep these in order. Now, since this is an angle that's written with 3 letters, we could abbreviate it and just say the vertex angle when we say ours. So we're going to say the measure of angle C is what to the measure of angle D. So is it greater than, less than, or equal to? And it turns out that C is greater than, because C is across from 3.2 and D is across from 3. Same thing on number 2, and now we're just talking about sides. So side JL is here, side KM is here. So keeping it in order, we're going to start with the JL and compare that to the KM. So JL is across from 47, KM is across from 81, so since 47 is less than 81, JL is less than KM. Same thing on this one, so now we're looking for QT and ST, so we're comparing those. So QT is directly across from the 80, and ST is across from 90. So then 80 is less than 90, so QT is less than ST. And on the next one, so we have the measure of XWZ. XWZ is this angle, and YZW is this angle. So that's across from 2.3, that's across from 2.1. So again, I'm just going to use the vertex because I can in this particular one. You couldn't do it if the vertexes were the same. Vertexes are different, so I can just use the vertex as my angle name. So the measure of angle W is greater than the measure of angle Z, because 2.3 is greater than 2.1. And on the back, we are going to apply algebra to the relationships in triangles. So basically, we're trying to find a range of values for x. So I'm looking at my two triangles. I see that the hinge theorem applies here because this side goes to both triangles, and these two sides are congruent, so we're going to focus in on this angle and this angle. So that's the included angle. So I always start with the one with my variable, so 6x plus 15, and I'm going to compare that, since that's an angle, to the only other angle that they gave me, which is 65. So is the 6x plus 15 greater than or less than the 65? And it is greater than, because 11 is greater than 9. So I'm going to solve that algebraically, and it doesn't matter that that's an inequality sign. You solve it just like you would solve any equation, except you just keep bringing down your inequality sign. So we're going to subtract 15, so we have 6x is greater than 50, divide by 6, divide by 6, x is going to be greater than 8.3 repeating. So most of the time, and sometimes this doesn't happen, but for the majority of the time, we need two inequalities. We need a greater than and a less than, because it's a range. So we have to say it goes from this to this. So since I have a greater than, let's see if we can come up with one for less than that makes sense in this case. So again, we're starting with the 6x plus 15, and we have to figure out what to compare it to. So since we're talking about less than and it's an angle for a triangle, or no, any angle, because the largest angle that we can have is a straight angle, which is 180. So this has to be less than 180. And then we solve that. And 180 minus 15 is 165. Divide by 6 on both sides. X is less than 27.5. So now I have the two numbers that I could use for my range. Remember, we start with the smaller number, the 8.3 repeating. We leave a space in the middle, so my larger number goes next. The X goes in the middle, and I put my two arrows. Now, I call them arrows. They're not arrows. They're inequality signs. So if we were going to read it, we would start here. X is less than 27.5, and reading in this direction, X is greater than 8.3 repeating. But as I discussed in class, I'm okay with you saying X is between 8.3 and 27.5. The only thing you actually need to remember is that 8.3 is not included in the answer and 27.5 is not included in the answer. All right, moving right along. So for B, here I have 2x minus 7, so I'm going to start with that because that's where my variable is, 2x minus 7, and it's an angle. The only other angle that they give me is the 41. So since this is across from 4 and this is across from 5, the 2x minus 7 is less than the 41. So when I solve that, I get 48. So divide by 2 and we get 24. So x is less than 24. Is there something that I can say that this also has to be greater than? Well, it has to be greater than 0 because that's the smallest angle that I could have. So 2x minus 7 is greater than 0. When I solve that, I get x is greater than 7 over 2. We can keep it as an improper fraction, or if you wanted to make it into a mixed number, that's totally fine. Or I'm sorry, a decimal, that's totally fine. 7 divided by 2 is 3.5. Either way, it's fine. So again, we're going to start with our smaller number, the 3.5, and our larger number, the 24, x, arrow, arrow. This is my answer. Looking at letter C, again, I'm starting with my variable x plus 20, and this is an angle. The only other angle that they gave me is the 41. So is x plus 20 greater than or less than 41? Well, it depends on what it's across from. X plus 20 is across from 28. 41 is across from 54. 28 is less than 54, so that's less than. And then when we solve it, minus 20, so we get x is less than 21. And could we come up with another inequality that's a greater than? Well, again, since it's a measurement and it's an angle, it has to be greater than 0. So subtract 20 on both sides and we get x is greater than negative 21. These are my two numbers, so negative 21, negative 20, not 21, negative 20, positive 21, x in the middle, arrow, arrow. This is your answer. This is the compound inequality. Next one. So this one looks a little confusing at first because the picture has the two triangles kind of close together. So this 12 goes to this triangle. This 3x minus 6 goes to this triangle. So again, just like before, we need an equation, and we're going to start with our variable, 3x minus 6. And since that's a side measurement, the side measurement that they gave me over here is the 12. And again, I need greater than or less than in there. So this one is across from the 41. This one is across from the 57. So 41 is less than 57, so less than again. Plus 6, I get 3x is less than 18, so x is less than 6. And can I come up with a greater than for 3x minus 6? Well, since it's a measurement, a side measurement, it has to be more than 0. We can't have a negative measurement. We can't have a 0 as a measurement. I can't say I live 0 miles from here. I can't say I live negative 20 miles from here. So 3x minus 6 has to be greater than 0. So when I solve that, I get x is greater than 2. I have my two numbers, and here's my compound inequality. So what this compound inequality means is x is any number that's between 2 and 6. Now, if it were whole numbers, and no one's saying that it is, but just if they said it was. If it was whole numbers, then the only numbers that could work here are 3, 4, and 5. But we know that it does not have to be a whole number. And on the last one, again, I'm going to start with the 5x plus 2 because that's where my variable is. This is a side length, which is across from the 55, and the only other angle that they gave me on the other side is the 68, and that's across from the 47. So I'm going to use the 47, even though they gave me some other numbers. This is the one that I need because it's across from the angle. So 55 is less than 68. Again, we get a less than here. Subtract 2 on both sides. We get 5x is less than 45, so x is less than 9. Then can we come up with another one? Again, since it's a side measurement, it's a distance, it has to be greater than 0. So we have -2/5, but if you wanted to make that into a decimal, it's -0.4. And as always, make your compound inequality start with the smaller number, then the larger number, then x in the middle, and your arrows. And that's your final answer.